These are little pivots that I'm making on the Unimat here. Cross-drilled them on my mill. These will be for the gimbal of the eyeballs of the Automata. Okay, these are gimbals for the eyeballs. We're going to solder this upright piece to the bracket that will hold the eyeballs. So we're going to solder these in, get them heated up. I fluxed everything, and let's see how we do here. Nope, not hot enough yet. I'm not very good at soldering, but boy, I sure do love it. It's just such a magical process. Okay, it's getting drawn in pretty good there. Do a little bit on the other side. You can watch the solder just suck into the joint. It's just such a, I mean, the word is magic. And we'll do the other one here. Put a little heat on it. Looks like the flux is boiling, and oh, not quite hot enough. Got to make sure you get plenty of heat into the brass. Okay, so I've got the gimbals pretty well rassled into shape here, and I'm just soldering up the little pivot points that'll go directly to the eyeball. I have a piece of a cross shaft here that I've put through the holes of these two pieces right here to keep the alignment, so I'll get good action on them. So here we go. You know, repeat of what you saw before. Flux is melty. And getting drawn in pretty nicely here. Heat it up. And solder is disappearing up into the joint very nicely. Heat this one up. The flux is boiling. Just about gone. And there we go. A little more heat on it. See if I can get it to suck up in there a little better. And there we go. So that's pretty good. Go ahead and do the other one now. Always tempted to pick these things up while they're still hot. So I have to, I've burnt my fingers many times. It doesn't seem like it should be. Oh, dang it. And this is the second eyeball. Flux is melted. And it's getting sucked up in there very nice. Thank you, capillary action. When I was learning about it in physics, I never thought I would appreciate it again. Capillary action. Ooh, got kind of a big blob on there. That's not cool. See if I can get that rassled back into shape here. Touch the other one. Scoop it around a little bit. And it looks like it's sucking up into the joint pretty good. I just have too much solder on there. So we'll get the brush on that. Let's see if I can find it here. Oh, that's actually pretty good. While I turned away, a lot of the solder sucked up into the hole, so we're in good shape on this. Okay, so I dreamed about making these things all night, how I was going to do it. So this is about 2 to 3 hours worth of work here. The little fittings are all hand machined on my Unimat over there. And I went through the process of soldering the joints here, and so now I've got these gimbaled eyeballs. And so the way they'll work is I've got the two of them there, and the mechanism will have them going side to side, but will also have the ability to have them go up and down as well. So I've got this basic part built, and now I have to think through what the next step is to get the coordinated motion I'm looking for. So another part that is integral to these kind of devices is cams. So these are just cut out of plywood. I actually made this plywood out of some finishing board and then glued them up and then cut the circles out using a hole saw and just did it on my drill press. Very simple. Got a box of these things. Came up with a jig to sand them smooth so they had a nice finish on the outside, and then just glued these together. And so I will be able to cross drill these and put a set screw in. Although when you use the hole saw with the 1/4 inch bit, it has a really tight fit on a 1/4 inch steel rod. So I don't even think I'm going to need a set screw, but we'll see when we start putting this thing together whether that'll be necessary. So this is going to be the little motor that drives the automaton, and this is something I got on eBay. They cost about $15, $16, free shipping. A nice little motor, turns about 10 revolutions a minute. It has it's about 2 inches in diameter, a little bit less, so it goes in a 2-inch hole very nicely. It's got these 2 little flanges here so you can screw it and mount it. The shaft, though, is a 7mm size, so it is metric, and I'm using 1/4 inch US fractional sizes for my shafts and bits and pieces on the mechanism. So I needed to transition, but I wanted to do it in a way where I had plenty of slop between these two things. So I manufactured this little bushing here. I guess you could call it a universal joint. It's a sloppy fit on the 1/4 inch shaft, and also sloppy fit on the 7mm stub for the motor.